Okay, so now in this example, we're going to show how to find the greatest common factor of these numbers. So let's do A first, of course. So let's write out the prime factorization of each number. Okay, so the prime factorization of 15 is 3 times 5. And then 30 is going to be, 2 times 3 times 5. Okay. And then 45 is going to be what? 3 times, well, it's going to be 3 squared times 5. Okay? So those are the prime factorizations. So now, what I'm going to do is to find the greatest common factor, I want to just write down the prime numbers that appear in all 3 factorizations. So what numbers show up in all 3? Well, 3 does and 5 does. The 2 doesn't, so I'm going to not even include that. Now, of the 3's, I want the one with the what? The smallest exponent. So that's going to be 3. And then 5 only appears with 1 exponent, so I'm just going to take 5. And so the greatest common factor of these, and the way I would write it, is I would write it as the GCF of 15, 30, 45 is 15. It's the largest number that will divide all 3. Okay? Now, what about this one? So let's do the same thing for B. So we got 10, 12, and 13. So now 10 is 2 times 5. 12 is 2 squared times 3. And then 13 is just 13. 13 is prime. Okay? So now, I want the largest number that will divide all 3. Well, in this case, it's going to be 1. Because there are no factors that are in all 3 factorizations. Right? There's 2 is in all 3. 3 is not in all 3. 5 is not in all 3, and 13 is not in all 3. So that means the greatest common factor that will divide 10, 12, and 13 is 1. So the GCF of 10, 12, and 13 is 1. And we're done. Have a great day.